post-test 1 review. Okay, and this post-test has several questions from each tutorial, and I'm gonna go by tutorial. 1, expressions. This post-test has 7 questions in this section. And actually, the problems that are in the tutorial, like the examples, are almost identical to the ones on the post-test. So if you took notes, hopefully you got those down. Some of those problems are on the guided notes. If you complete the guided notes, some of them are not. Here's a list. Make sure that if you want to review, go back to tutorial 1, pages 8, 9, 10, 13, 15. Pay special attention to the video on page 16, 17, 22, and then pages 24 and 25. I will go over some of these problems, but I'll try to get to as many as I can from the other ones as well, from the other tutorials. I'm going to begin with the first problem. Problem is from tutorial 1, page 10. Can everybody see the problem? Is it too small? Is it too big? Can you read it? If you guys are good, please type in the chat. Okay, for this one, we're gonna use the order of operations to evaluate. What does that mean? That means that we're gonna use something called PEMDAS. What is PEMDAS? This is that when you are presented with a problem and you don't know how to begin working on it, you gotta check this order of operations. You start with parentheses. Please, problem, see if you have any parentheses. This one and this one. Okay, so we're going to start with this one. -2 plus 1 is -1, but I'm going to keep the square. 5, parentheses, and then 12 divided by 3 is 4. Minus 9. And that's it. I'm done with my parentheses. Now I got to check again. I still have parentheses, because there isn't anything inside the parentheses to do. Now this changes to something else. Very first one, I notice that I'm raising it to a power. That's an exponent. So I have to do that. -1 squared, that means that you're going to multiply -1 times itself twice. So this is -1 times -1, which is 2. And then 5 times 4, 20, minus 9. Okay. All right, so I'm done with parentheses. I'm done with exponents. I'm done with multiplication. Don't have any division. And now I check if I have an addition or a subtraction. Now, addition doesn't necessarily have to come first, is whatever comes first from left to right. First, I have 2 plus 20. I'm going to do that. It's 22. 9. 22 minus 9 is 13. So this is the first question. This is the first type of problems that you're going to see on the post-test. If you need extra practice, please let me know and I'll go over the next problem with you. Okay, so let's go to problem 2. Another problem that is going to be very similar to what you're going to see in the post-test is just problems that ask you vocabulary terms. For example, they're going to give you an expression, ask you what each part is. Now, I got this little screenshot from your tutorial, the one where it explains what each of them are. So let's try to figure this out. In the first term, one right here, 3 is, okay, so we have 3 is the number next to the letter. The number next to the letter is called a coefficient. If you have a question like this on the post-test, you'll just select coefficient or type coefficient. Same thing with the second one. Second term is x plus 2. Look at the list and see what it kind of looks like. It kind of looks like a term. Kind of matches what we have here. But look at the word term. Here the 4n and 7 are highlighted. We have two terms. Kind of tricky there because they're asking you for this whole thing and it has a parentheses. Every time you see a parentheses next to a number, it's like you're multiplying. Two things that are being multiplied to each other, factors. This would be a factor. Okay. The last term, 4, is there by itself. It has no variable, just a constant. Make sure you review the vocabulary, and you'll be good with this type of problem. Okay. Number 3. If you want me to go back to any of the problems, please let me know, or let Miss Johnson know in the chat. Okay, the next one, simplify this expression. This looks similar to the first example. The only difference is that now we're going to be dealing with variables, and they're going to be part of our equation response. Simplify this expression. We have 4 parentheses 1 minus 2b plus 7b minus 10. Okay, let's check our order of operations. Parentheses. Okay, we have a parentheses here. Minus 2b. I can't actually subtract these two quantities because one is a variable and the other one hasn't. Okay, so what's next? Exponents. We don't have an exponent. Multiplication. We actually have a multiplication here. Every time you see a number in front of a parentheses, that means that we're gonna multiply these two. Okay, so how are we gonna multiply this? Something called a distributive property. I'm gonna take the 4 and I'm gonna multiply it to inside. 4 times 1 is 4 minus, and then I'm gonna multiply it to the second term. 4 times 2b is just 8. And I'm gonna bring everything down. Once you get to this point, you're gonna see if there's anything that you can multiply. We don't have any multiplication anymore. We don't have any divisions. Let's see if we could add or subtract. Now the key here is that you have to make sure that you add or subtract like terms. What do I mean by that? Like terms are quantities that are of the same type. For example, 4, -10 are like terms because they're both numbers without a variable. I'm going to go ahead and combine those two. 4 minus 10 is -6. Then I combine the other like terms. Now I combine the ones with the letters. So -8b plus 7b, -b. Now I have a number and a term with a variable. I can't do anything else to them. I can't combine them, so that's it. I'm done. -6 plus 1b. I'm going to make it a capital B because it kind of looks like a 16. Sorry, one moment. Oh, okay, thank you. Yeah, I meant -6 minus 1b. I think I said plus, sorry about that. Okay, I'm gonna move on. Anybody have any questions about this problem? Okay, all right, let's move on to the next one. Okay, this one is on page 22. The question is, what is the value of this expression when a is equal to 2 and b is equal to -3? Something that I wanted to point out is when you have something like a fraction like this, 1/5 times a cubed minus b cubed, this is the same as a cubed minus b cubed divided by 5. So multiplying by 1/5 is the same thing as dividing by 5. Both of these representations will be in the post test, so make sure that you don't stress out too much about those. If you are more comfortable with doing division, if you see anything like this, just rewrite it as this. So now what do I have to do with it? How would I simplify it? Here, I don't know what A is and B is, so I have to check, see if they actually give us that information. A is 2. So what I'm going to do, I'm going to rewrite this. Instead of writing it as A cubed, I'm going to write it as 2 minus, and then instead of B, I'm going to check what B is, and they also give us that's -3 cubed. I'm going to do that, and then I'm going to divide by 5. Now let's solve it. Oh, space. 2 cubed. 2 cubed is the same thing as 2 times 2 times 2. You don't multiply 2 times 3. That's a very common mistake. 2 times 2 is 8, so 2 cubed is 8. Minus, same thing with -3 cubed. This is the same as -3 times -3, -3, which is -27. Divide by 5. Okay, now I have two negatives. 8 minus -27. Negative and a negative turn into a positive, so I'm just going to rewrite this as 8 plus 27 over 5. No, it's right here. And 25 plus 8. Oh, sorry, 27. 27 plus 8. 35. 35 divided by 5 is 7. Okay, if you need me to go over anything, please let me know. I know I'm going a little bit fast because I'm trying to get through as many problems as I can. For this problem, make sure that if you see a fraction times a quantity is the same thing as this quantity divided by the denominator. Okay. All right, I'm going to move on to the next problem. Okay, you're gonna have a couple of questions where you have to find the mistake in the steps. So we're gonna go over. You're gonna have something like this, and a lot of times the mistake, let's say if it's in step one, you won't really see the mistake until the next one. So let me show you what I mean by that. We have 4 squared divided by 2 plus the absolute value of -6 by -3. Okay, so let's go to step 1. What's different? What's different is 16. 4 squared is 16. Okay, so that's good. Plus absolute value of -6 was left alone, and divided by -3 was left alone. Okay, let's go to the next one. The next one is 8, and we get that from 16 divided by 2. Okay, so that's good. An absolute value that's inside of the absolute value will turn out to be positive. This is +6. Okay, so that's good. You have divided by -3. They did not take the absolute value correctly. The absolute value of -3 should be +3. This should have been positive. Even though the mistake was made here, you really see it until you write it in step 2. So the mistake is actually in step 2. It did not take the absolute value properly. All right, let's move on to the next problem unless anybody else has any questions. Okay, tutorial 2, linear equations. There are 8 questions in your post-test that are from this section. They're going to be very similar to your tutorial. Pay attention to the video on page 8, especially pages 15, 16, 18, and 19. We have problems that are very similar to the post-test. Also, if you would like practice in solving for a variable, you can visit the math website and complete the extra credit activity. And I can show you right now. Department website, hopefully you got a chance to look at it. If you go to Algebra 1A, click on extra credit on the left side. It's kind of slow. We'll see a Google document with practice problems to go over. This is very similar to the format that your Khan Academy activities are at. Instructions are on the left side. What you have to do is on the right side. It has videos if you need extra practice. If you need any help or would like to complete it, please let me know and I'll be happy to navigate this document. But anyways, back to the post review. Let's begin doing a few examples. Example 1. Create and solve a linear equation that represents the model. Circles and squares are shown evenly balanced on a balance beam. Now, when you solve for an equation, it's also called balancing an equation. That's what they're trying to show you with the balance. So, of the balance represents the equal sign. The circles is just the number of circles that you have on each side. On the left side, I have 5 circles. And on the right side, I have 2. And then I have a box. It's like, well, how many circles do I need to put in here so it matches what's on the right side? Don't know, Instead of writing a box, you would write it as a variable. 2x equals 5. You're going to be asked to solve for x, a comma, is equal to. You can solve this doing the steps that we're going to talk about in the next problem, or you can just see if I need 5 circles and I already have 2, I'm just missing 3 more. 1, 2, 3. So it matches what I have on the right. So my answer will look like that. I'm going to have the equation that I need to come up with, and I'm going to have a semicolon, and the answer is going to be on the right side.
Janice, is that 2 times x it looks like there? Supposed to be a...
It's a 2x. Does it look like something else?
2 times 3 doesn't equal 5.
Oh, that is true. Thank you, thank you. I'm missing something in between. This should be a plus. Thank you. Another good skill to have. Does your answer sense? Does it make sense to, yeah, because 2 times x will not give you. Okay, thank you for that, Miss Johnson. Okay, now let's move on to the next one. Do any of you have any questions? Okay. The next one, what value of n makes the equation? So here, the goal is to get n by itself. And to do that, we need to get rid of everything that's around it. This one and this number right here. The only way to do that by doing the opposite operation of each one. So let's say I want to get rid of 11 here. Rid of 11, I'm going to subtract 11. The opposite operation of an addition is a subtraction. I'm going to subtract 11. In an equation, whatever I do to one side of the equal sign, I have to do to the other. So now 11 minus 11 will be 0. So I'm going to out. I didn't do anything to negative 3 over 4n, so I'm going to bring that down. 5 minus 11 is equal to negative. N is almost by itself. Now I have to get rid of this fraction. To get rid of this fraction, you multiply by the reciprocal. That means on this side, I'm going to multiply by negative 4 or 3. And whatever I do to one side of the equal sign, I have to do it to the other. Now, when I multiply this out, negative 4 times 3 is 12. I'm going to have 12 over 12n equals negative 6 times 4 is 24 divided by 3 over 12 simplifies to 1. This becomes 1n equal to 24 divided by 3 is 8. And to solve for n, 1n, just write it as n because to get rid of that 1, would divide by 1. 1 divided by 1 is 1, or you can cancel it out. This is the same as n equals, and 8 divided by 1 is 8. Now, this is another example of solving an equation without the balance picture. This you have to do operation of what you see to get the variable by itself. Okay, I'm going to move on to the next one. This one, 19. I'm going to put a star here. Very important and very similar to something that you will see on the post test. Okay, so let's break it down. Celine is Drake's daughter. Age is 4 years greater than 1/3 of Drake's age. If Celine is 28 years old, how old is Drake? Okay, so we have to pick the equation that matches the situation. All right, so first, you know that you have two people. You have Celine, you have Drake. Celine is Drake's granddaughter. Okay, so that information is not too important. All we know is that Celine has to be younger than Drake. Her age 14 is 4 years. Okay, so I'm going to start writing something that 4 years greater than. Now I'm going to translate this into a mathematical symbol, and I'm going to select one of the main four, which is addition, subtraction, multiplication, and division. Greater than, so she's 4 years older, 4 years more, 1/3 Drake's age. Is 28 years old. How old is Drake? How old Drake is. So because we don't know, let's give it a variable. Now instead of writing X for the age of Drake, I'm just gonna write D. D for Drake. That's all the information that we have on Drake right now. I'm gonna go back to Celine's information. And I'm gonna erase Drake. So she's 4 years greater than 1/3 of Drake's age. And I'm gonna replace the word Drake with D. 4 years greater than 1/3 of Drake's age. Okay, and then it says if Celine is 28 years old, so they're already telling you how old Celine is. She's equal to 28 years old. How old is Drake? Okay, so we have the first equation. 4 plus 1/3 D equals 28. And that is this option right here. Even though they wrote the 1/3 first, it's okay because for addition, doesn't matter which order you put it, because you when you add them, you'll get the same thing. Something that you will be asked to do in the post-test is once you find the equation, you're gonna have to solve for the variable. I'm not gonna do it right now because I just did a very similar problem in the previous problem. And you can go back to this tutorial page and it'll do it for you on part B. This is just part A. If you have questions on this or think that you might need more practice, let me know. Does anybody want me to repeat this? Good. Okay. All right, let's move on to the next one. You're gonna have a question that is, again, like they're gonna give you some steps and they're gonna ask you about the different. So, question 1, in which step is the division property of equality applied? Step is the multiplication property of equality applied. Two different questions. Okay, so before we try to figure this out, let's just see what they're doing in the steps. Step 1, 6x minus 9 equals 45. Okay, so they're not doing anything here. This is just what they're giving us. Now let's go to the second one. 6x minus 9 plus 9 equals 49 plus 9. Here, the plus 9 is different. So what they did here, they added. Call the addition property of equality. Am I writing? Addition property of equality. Now, property of equality, that just tells you that whatever was done to one side of the equal sign was also done to the other one. That's it. That's all the property of equality means. It was just done to both sides. Okay, so it was added, and then in step 3, you end up with 6x equals 54. Nothing was done there. It's just, they actually added it, so this is called simplification. They just simplified. Step 4, they are actually dividing by 6. Because they're doing it to both sides of the equal sign, they're actually doing the division property of equality. And the answer is just simplification. Okay, and in your post-test, your answers, you will have multiple choice questions. But still, I wanted to write them like that so you can kind of take note. 1, which step is a division property of equality applied? Step 4, this is when we divided both sides. So this would be step 4. In which step is the multiplication property of equality applied? Problem, nothing had to be multiplied, so none of the steps. All right, let's move on to the next problem. And finally, tutorial 3, radical expressions. You have 7 questions on your post-test from this section. And again, a lot of the problems in your post-test are going to be almost identical to the ones that you see in your tutorial. So please make sure that you go back and review this. And for this, you have to be somewhat comfortable with square roots. And if you don't remember a certain square root, it's okay to use this little cheat sheet as reference. So now I'm just going to do 3 examples here. And then we'll be... Okay, the first one. Simplify square root of 18. The very first thing that you want to check is, does 18 have a square root? So I'm going to check my list. I have square root of 1, square root of 4, square root of 9, square root of 16, oh, square root of 25. Nope, we don't. It should be somewhere in here, but it's not. Okay, so when a number does not have a square root, we have to do a couple more steps. First thing I want to do, I want to break this down to 2 numbers. I want to multiply, I want to find 2 numbers and multiply to 18. And the first ones that come to my mind is just 9 and 2. Okay, then you start all over again. Does 9 or 2, do any of these have a square root? So you go back to your list. Actually, 9 does have a square root. The square root of 9 is 3. So this just becomes square root of 2, not have a square root. Then when you get to this point, you usually want to break it down again. Find two numbers that multiply to that. Nothing else multiplies to 2 than 2 and 1. So there really isn't anything else we can do to simplify it even more. Because we can't simplify it anymore, we just bring it down and that becomes part of our answer. The square root of 18 becomes 3 times the square root of 2. And then could I have picked other numbers? Sure. Well, you could have picked, let me see, what else multiplies to 18? Is there any other numbers that multiply to 8?
3 times 6.
Oh yeah, 3 times 6. Yeah, you could have done that too. 6. But it's usually good to try to find numbers that already have a square root because it'll make things a lot simpler.
Typed in the chat to use the numbers in the right column, 1, 4, 9, 16, 25, because those are the numbers that have perfect squares.
Yeah, thank you, Ms. Johnson. Yes, and if you can find a list that has like a longer list, feel free to search the internet, look at resources, because then you're gonna have things like square root of 96. So let's try to do the same process. So what multiplies to 96 has a square root? Okay, so I could look at a list and then probably take a long time because this is such a huge number. So I'm gonna do it a different way. This is how it is explained in your tutorial. So 96 ends in even number. I know that it is divisible by 2, so it's gonna be 2 and something. 2, and then I'll just go in my calculator. 96 divided by 2 is 48. So 2 times 48. Okay, I know that 2 cannot be simplified anymore. So that's fine. I'm going to leave it there. And I'm just going to keep breaking this one down. So I'm going to divide it by 2. 48 divided by 2 is 24. And I'm going to keep breaking it down. 2 times 12 gives you 24, and 2 times 6, and then 6 is 3 and 2. I'm gonna do, just gonna circle all the ones I couldn't simplify because you can't simplify them anymore. And on the side, I'm gonna rewrite them all in under one radical. This is called a radical. So I have 1, 2, 3, 4, 5 twos. 1, 2, 3, 4, and then a 3. Okay, now in here, I'm actually going to find 2 times 2 is 4. 2 times 2 is 4. And I'm just going to multiply these out because I don't find a pair that's the same. Actually, I'm not going to circle them. I'm just going to put them together. These are the leftovers. These are the ones that didn't get circled. Okay, and all of this is being multiplied. Why I separated them is that now that I went all the way down, I can actually see that some of these actually have a square root. 4, the square root of 4 is 2. And then the square root of 4 again, 2 times. And inside the radical, there's nothing else I can do to simplify it but multiply. 2 is 4. And I have 4 square root of 6. This is another way of simplifying these radical problems. Now, could you have actually come up with two numbers from the beginning that actually have a square root and make it easier so you don't have to do all the steps? Probably. You know, there's more than one way to do this. If you're really blanking out and you're like, you know what, I don't know, I'm just going to divide everything by 2 and do it this way works every time. This way also works with 18. Anyone, but this works with any square root. It's just that this is just it's gonna make the process a little bit longer. But if you're really blanking out and not you can't think of any number that multiplies to 96 that has a perfect square root, just break it down like this. The tutorial has a lot of practice problems like this, so make sure that you go back and check those. Or if you did the guided notes, take a look at those and make sure that you understand the steps on how they did it. Okay, now we're going to do a different type of problem. We are multiplying two radical expressions. What is this expression in simplified form? 4 square root of 5, and then 5 square root of 3. This is also from your tutorial. In your tutorial, they put two examples like right next to each other, so it looks like it's one big example. It's not, it's actually two. So I'm gonna break this one down. All you have to do is multiply numbers that are outside of the radical, 4 times 5. And then you're gonna multiply everything that's inside the radical, so inside the square root. And 5 times 3. 4 times 5 is 20. Then square root 4 times 3 is 15. You can't actually simplify it anymore, so you're done. Most of your post-test questions from this section of your unit are gonna be like this. They're gonna give you a radical expression and you're gonna break it down and simplify it. So this is it for today. I know that I went a little bit fast because I wanted to get to through as many examples as I could, and I also wanted to make some extra time in case any of you have any questions. If you have any questions you'd like to ask now, please let us know in the chat. And if you are not entirely sure, if you didn't understand anything that I did and would like to have a separate appointment time with either Ms. Johnson or myself, please let us know by chat. And chat are, actually I'm gonna type it. If you use Google Hangouts or your email, just look for MKA Janus at sthevirtualschools.com or Miss Johnson, R. Johnson at sthevirtualschools.com. And if you're used to working with another math teacher, that's fine. On our website, oh, actually I have it open. And you need help from a math teacher and you don't know how to contact us. We're all here. Our contact information is here. Now look for us. So today, that's me. That's one that did the lesson. This is Miss Johnson. She helped me out today. A lot of you work with Mrs. Justison. Then we also have Mr. Goodson, Miss Perez, and Miss McDonald. Any questions about this, please let me or any of these other teachers know. I will try to have this review on the website. Hopefully today, but for sure this week. I'm gonna review it. Okay, is there anything else that I can do for you guys? Any questions? Any questions?
Not received any questions? No.
Awesome. Well, thank you very much for joining us. And I would really appreciate if I could get some feedback. If you feel like this was useful, uh, Ms. Perez and I are, and Ms. Johnson from time to time are planning on doing this once a month. Do you find this useful? Would you be attending these live stream lessons? Do you think I was going too fast? Please reply to that email that I sent you, and I would love some feedback so we can improve in the next live streams. Okay, so this is it for today. Thank you so much for joining us, and let us know if you have any questions.